Okay, so we're going to look at solving all log equations. So we're going to kind of mix all the different equations that we've looked at. So how do we know what to do when we look at an equation? So here are some rules. First, if there are no logs, for example, right here, it says simplify first if necessary, meaning undo any adding and subtracting, undo any multiplying and dividing. And once you get it down to this basic format, then take the log of both sides to solve for the variable in the exponent. Okay, so you might notice that would look like number 2. That would be an example of rule for this first example. Notice there are no logs. So number 2 fits with this one here. So let's do this. Let's go ahead and follow this rule. It says simplify if necessary. So looking at this, notice we want it to boil down basically to just this format right here, okay, before we take the logs on both sides. So like I said, we undo the adding and subtracting first. We undo any multiplying and dividing. So notice how we have it boiled down basically to this form. Okay, and then it says to take the log of both sides to solve for the variable. This should be very familiar to you by now. Bring the x down front. And then divide by log of 5 on both sides. And yes, we'll need to use our calculator on this. So x is going to be about, let's take a look here. Got the log of, what was it, 4 on top, divided by the log of 5. And we'll go 3 decimal places, so 0.861, about. Okay, let's look at the next one. It says log terms on one side. If you have log terms on one side, simplify, and then rewrite it in exponential as an exponential equation. So notice how we have log terms on one side. So let's see, do we have any of those going on here? Here we go, we have log terms on one side. No log terms on the other side. So for number 1, we're going to use these rules. It says to simplify. So that would mean condensing. So we could condense this right here, since it's in parentheses, right? And we're simplifying this, right? We do parentheses first, so we're going to have 2. And then this is going to condense. The bases are the same. So this is going to condense. Since we're adding, remember the rules. You multiply the arguments. Okay? Still, we can still simplify a little bit more. This is multiplication, so we can undo multiplication with division. Okay? That's as far as we can simplify that. So now what does it say? It says rewrite it as an exponential equation. So we're changing forms. So remember, when changing forms, we always start with the base. Okay, then we raise it to the exponent, and we set it equal to the argument. Okay, so we have 2 to the 4th power, which is 16, equals 5x divided by 5. So x is going to be 16/5. And yes, I would leave it as a fraction. And remember, check to make sure it is positive. If you plug it in, the argument is positive, so we're good. All right, C. Here's when we have log terms on both sides. So notice in the example we have log terms on the left and we have log terms on the right. Always note that the bases are the same. Okay, it says simplify to get one log term equal to one log term. Okay, then we're going to use the property to make m equal to n. The two arguments, we're going to make them equal to each other. So let's simplify the left. So first thing we do is we bring that 3 up on the 2. Now we only have one log term on the right, so there's no simplifying needed over here. Okay, continuing to simplify, we can condense these down. Adding means to multiply. So 2 cubed, which is 8. 8 times x is 8x. Oops. Thank God for erasers. All right. So they're both base 10. Bases are the same. So the property says that once you have one log equal to another log, as long as the bases are the same, we can. Now the math here is raise both sides or to base 10. So that cancels it out. So 8x equals 24. And x equals 3. So 3 types of problems that you're looking at, okay, and you need to know what to do when you see them. All right, and so we'll practice this in class. We're going to have a quiz on Thursday, okay, over solving log equations, the different types. So be ready. Hope you're having a good night. Oh, if you're still listening, because I was thinking about somebody who wanted a shout out. So this is a shout out for Luca. So there you go, Luca. Now you owe me $1. Just kidding. Just kidding.